Hello, my name is Tommy and I'm presenting you my project about French English neuro-machine translation. The goal of my project is to create a machine to translate French into English. And as you may know, neuro-machine translation has been used by Google, and Google Translate has been used by more than 1 billion users. So let's take a look at the structure of the project. So I have 6 steps of the project. First, I import the libraries and datasets. I did some data cleaning and visualizations, and then tokenization and padding. After that, I build and train long short-term memory neural networks. And the last step is to assess the model performance. So let's get started. So first of all, I import the dataset. I found the dataset on Kaggle. My dataset has 137,000 rows of parallel data. So I'm going to use French as my input, and based on French input, I'm trying to generate English translation, and with that translation, I can compare it to the original English sentences to judge the accuracy of the model. So the data set is very simple, 2 columns with 137,000 rows. And then I imported some Python libraries. So pandas and NumPy were used for data analysis. And for natural language processing, I use NLTK and Jensen. Matplotlib and Plotly were used for data visualizations. And scikit-learn was used to split, train, and test data. And last but not least, TensorFlow Keras libraries were used for building and training my model. And then after the importation, I did some data cleaning. So I removed the punctuations from the English and French phrases, and I found that there are 199 unique English words and 350 unique French words in my dataset. And in the bottom, you can see the top 5 most used French and English words. The most common English word it was used more than 200,000 times. And then I try to visualize the frequency of the word count. So as you can see, the word is has been used the most, more than 200,000 times. And on the other hand, some other words at the end, you can see strawberry, peaches, and grapes. They were used less frequent. And one of the issues with the machine translation is that rare words are susceptible to be translated incorrectly. So you can see at the end, my model has had some trouble translating some less common words. Okay, and then I did another visualization on word count. So this is word cloud. Yeah, word cloud on the French dataset. So you can see some of the most common French words. Il est, the word il and le, it means it is in English, and obviously is the most uh, most popular words in the French language. So after visualization, I did tokenization and padding. So as we all know, computer can only works with numbers. So the purpose of tokenization is to convert uh, a string of text into a sequence of integers for analysis. And after the phrases were tokenized, I added some paddings to make all the sample sentences to be of equal size. Let's look at an example. So we have a French phrase and an English phrase. So the sentence was transformed into a sequence of numbers. So the first numbers are 84, 120, 16, etc. They were the tokens, and the zero at the end, they are called paddings. So all the phrase won't be of equal size, which is 23 words, the longest number of words in a French dataset, and 15 for English. That is the length of the longest sentence in the English word. If a sentence is less than 15, then we added the zero at the end. Okay, so after data preparation with tokenization and padding, I start to build and train my model. So I take the French input and then it's go through several layers of recurrent neural networks. We have encoder layer of a long short-term memory network, and the decoder has a repeat vector and another LSTM layer. And last one is a time distributed layer dense. And then we can generate the English output. So my model is sequential. This is the code from my Collabori Python code, and the test size is 20%. I trained it for 17 epoch, and the accuracy I got is 97.8%. And you can see all the layers, and then summary at the end. Okay, so this is my result. So I'm giving you two examples. Example one, the translation works pretty well. It's only some of the words were incorrect. So I took the original French sentence, I generate the predicted English sentence, and then we can compare the predicted English sentence with the original English sentence to see if it's correct or not. So in the first example, most of the words were correct except for the banana and peach and her and my. So as I mentioned earlier, the the name of the fruits was some of the more or less no some of the less frequent used word. So that might be one of the reason why the model got it wrong. And in the second example, yeah, the predicted English sentence is, I think, totally different from the original English sentence. So I think that's one of the limitation of my model, is that I did not have enough data, and also the model could be more complex, so it can improve the accuracy. So this is my reference. One is from the book, TensorFlow Deep Learning and Projects. It has a machine translation project, and also I learned from a Coursera course called Long Short-Term Memory Networks. So I think that's it. Thank you for watching my video.